Hey guys, welcome to DSA-n-Design. Today we will look at one of the very important concept, and I would say it's very basic thing also to understand. Uh, Basically, it's about how do we recognize whether given two algorithms, right? Which algorithm is better performing or which algorithm is better to choose, right? So I'm sure given we can actually solve one particular problem with multiple ways, right? But it's very important to know that um, which way is better than other, right? And which one is the best among this, right? So we were going to discuss something about on this line, and so I'm sure that you must have heard about time complexity, right? Time complexity. Uh, we also call it as TC, right? Time complexity and space complexity, right? So what we will do is we will try to understand time complexity in this lecture, right? And how do we basically, what is time complexity first, and how do we actually calculate, and everything about around it basically, right? So first of all, we try to understand basically how do we, so let's say, I'll just take an example and then we'll try to understand here that let's say I have two algorithms, right? Algorithm 1, algorithm 2, right? And I have these two algorithms. How do I ensure that one algorithm is better than other, right? How do we ensure? So first of all, we can easily say that which algorithm is basically able to complete in lesser time, which means basically the execution time is lesser, than that algorithm is good, right? But here comes several factors as well, right? So for example, algorithm once, let's it's taking 5 seconds, okay? 5 seconds to execute, and algorithm 2 takes, let's say, 10 seconds. If I ask you which one is better, so you obviously say that the one which is taking less time, which is algorithm 1, right? But that's not all, right? How? Because let's say this particular algorithm is written, first take a lot of factors, external factors that I'm talking, right? So let's say this has been written using C++, right? And the machine that we are using, let's say it's a MacBook Pro probably, yeah? And here we are using Windows machine, something, and we are using here, let's say, Java, isn't it? Now, we all know that C++ is much faster than Java, right? And then MacBook is obviously better than Windows machine, right? Now, we can't simply say that, it's taking lesser time, then this is basically better, right? Lesser time doesn't mean that, right? And another factor could also be there, right? Another factor could be, give me a second. Okay, another factor could be that maybe this person, where he is coding, right? It's a quite cold place. For example, let's say this person is in Alaska, right? Performance of the machine here is much better, and this person, let's say, he is sitting in somewhere on the South Pole, or it's very hot, right? On somewhere on lava, right? Imagine. In that case, obviously this particular algorithm is going to perform much better, right now. So there are a lot of external factors, right, which actually can influence it, right? So that's the reason it's not good way to say that execution time is kind of is a good way to measure which algorithm is better performing, right? So in that case, we have got another way to do is the number of iteration, right? Number of iteration, when I say given an input, how many iteration it is taking to complete that. So for example, let's try to understand a little bit about number of iteration, guys. So let's say I have uh, I have a code which is basically a for loop. All right, so I'll just say n I plus plus, and then here I'm saying print I. All right, and this, let's say this is in a function, let's say void function. All right, and here input is n. All right, now this is something, a kind of a code, for example. Now, based on this particular input, let's say I'm giving n particular n, the input size is basically n. and here it is actually going to iterate to all this n cycle, right? This is basically in this case my iteration is going to be n, right? Because I'm actually iterating it n time 0 to n minus 1, correct? So how we actually calculate it? This is n minus 1, basically this one, this is less than n, no? So n minus 1 minus 0 plus 1 basically. So this is gone, which means n iteration, total n iteration, right? This is how basically we calculate it, right? And then let's try to understand one more example. Basically, how do we calculate number of iterations? So for example, let's say I have this function, right? And I have n input here. Now I have a for loop here, I equal to 0, I is less than 100, let's say, I plus plus. Now if I say print I, correct? Now tell me, what is the iteration here, guys? Is it n or it is basically not n? Exactly. This is not exactly n. So we are giving n input, but actually my iteration, so this is independent of n basically, because this you see how many times my for loop is running basically, it's almost 100 times, right? Which means 100 based on my input, if I put here 10,000, 50,000, whatever number I put, my loop is going to actually execute only 100 times, which means it is basically a constant, right? Constant time, correct? So this is how basically we calculate it, right? The number of iterations, right? Now let's not go too much about it, but we will try to understand basically the main thing. How do we actually use these iterations to calculate the time complexity? All right. So let's try to understand it. So we have got something. So it's not very easy to calculate the uh, iteration, because here it is easy because we can easily know that, but there are a lot of algorithms where we have lot of iteration in between happening, right? So in that case, we can't actually just say that. For example, let's say I have a function, right, which is taking something like this, guys. Let's say 2n plus 100, correct? Maybe here n square. All right. So these are basically input size and these are the iteration. So n square iteration means what, guys? Basically there are two for loop, like for loop, this is going for n times, and then again inside that I have another for loop which is again going for kind of n iteration, right? So that's making basically n square, right? If a single for loop, then it is actually for the input size n, it is n actually, right? For example, let's say my algorithm is actually consisting of entire thing, right? Then how do we actually know that how much iterations are there? It's very difficult to kind of ensure this, right? And to basically simplify that, we have something called asymptotic notation, right? So we have got something atom asymptotic analysis, right? Asymptotic analysis of algorithm. All right, let's try to understand of algorithms, right? So this is something what it says basically. It says that it basically kind of help you to get the performance of algorithm, right? It will help you to get the performance of the algorithms for very large inputs basically. Okay, so how do we actually calculate this asymptotic? So we have something called, a lot of notations are there, but mostly we are actually using in industry big O of one, I mean big O notation basically, right? Big O notation. And what actually this says that there are couple of rules for the big O notation. So for example, let's say my algorithm is having something like this. This is basically the equation for my basically the cycles, right? These are the number of iterations, let's say. What big O notation says that, okay, there are couple of rules that it says, right? It's not easy to like, get the time complexity and all these things. So big O notation is something that basically says that how actually you can figure out the time complexity, which means how much like iteration it need to have and all. So to simplify this basically big O notation, there are a couple of rules that let's try to understand all those rules. First, it says calculate uh, calculate iterations, yeah, number of iterations, iterations based on input size, right? Based on input size, correct? This is first thing. Okay. Now, second, it says that ignore lower order term. We'll try to understand, don't worry, lower order terms. Okay. Third, it says ignore constant coefficient. Okay. Coefficient. We'll try to understand all of these, guys, don't worry. But let's try to understand first basically what I mean to like one by one, right? So in this case, if I can say you that calculate the number of iteration based on input size, right? So let's say I calculated for a particular algorithms. Let's try to basically write something here and try to understand how it works basically. So for example, let's say I have a function and this is that n input, right? And here it has something called for, I'm not going to write full code, guys, okay? So for n input and then another for n input here, and here I'm going to do printing something. Then again I have another for loop here. So this for loop is basically okay, this for loop is finished. Now I have another for loop here starting, and it says that for n input another for loop for here, again an input, and then one more. So these are the nested for loop, guys. Three for loops are there basically, and then there are some constant operations. Now if I ask you how do you actually calculate the total iteration, right? So it's very simple, right? Because see here it is, this code is giving you n square, right? And then if you come down here, it basically three nested for loops, right? So this is n cube, right? For a given input n, so this is my equation now, and there are some constant operation, let's say 10 something like that. So my function will be like this basically, n square plus n cube, isn't it? This is how it is, correct? So this is my function basically, and maybe some constant, right? So let's say 10, 20, whatever, right? But this is my function, so this is what it means. So first, given an algorithms, what basically to find out a big O, what we have to do, we have to first calculate the total number of iteration, and this is what it is basically. So let's say for that particular below algorithms, we have got n cube plus n square plus 10 maybe, yeah, okay. Now it says that okay, how do you get the big O? So first of all we got this one. Now on top of this, the second step says that ignore the lower order terms. So which are the lower order terms? Now you see here the biggest order term is basically n cube, and n square is lower order term, and this is also lower order because n cube is the highest one, the biggest one, right? That's why what we have to do, we have to basically ignore this two, right? We have to just remove this two, ignore this two, right? Now what is my resultant? It's basically n cube after this, right? And the third rule that we apply, we say that ignore constant coefficient. Here we don't have, okay, here we don't have any constant here, okay, constant coefficient, so that's fine. Let's say for example it is maybe it is 10 maybe here, 10 n cube plus n square plus something like this it is there. Then after this I should have this kind of things, right? Because I ignored the lower order term, this two, but I still have 10 n square. Now here if I say ignore constant coefficient, then I will be just ignoring this 10 actually, and my big O, right, time complexity big O, it will be what? It will be n cube, because here I am going to ignore the constant coefficient, which is 10 actually, right? So this is basically how I can get the uh, time complexity, right? Hope you got it. And this is basically the time complexity, how you calculate, right? And I mean, this is the simplest way. Like I just try to help you like how we can actually find out the big O notation, basically the time complexity, right? Now, what we will do is, um, for now we are able to understand, right, what is time complexity. Time complexity is basically nothing just to find out the big O of what basically. So we all, how do we indicate it? If somebody is asking, like anywhere you go, right, for any of the DSA constant, they will definitely ask you what is the time complexity, what is the space complexity, right? So that's the reason we have to understand it. So we have to tell, we have to basically indicate this. Big O is indicated like O, and how much is the complexity? Let's say in this case NQ, right? So order of NQ, I will say big O of n cube basically. This is the time complexity, right? Now, so this is the way, right? And now if I have, let's say, some function, let me give you one more example, guys, so you can better understand, right? So let's say I have another function, for example, void. I will not write everything here. Okay, there are n input here, right? Now what I say, I will say it here. Let's say I have some print, right? Some print statement here. Okay, and then here, let's say I have something called for loop n. Okay, and something I'm going to do it here. Okay, and then again I have something called for loop 1n. It is running, for loop is running on the n input. Okay guys, fine. I'm not writing the whole code. I hope you understand, right? And now this for loop is also running on nq. Now there is another for loop, guys. Okay, there is another for loop here. Okay, in the entire thing, which is basically starting from I equal to 0, I less than 100, and I plus plus. Okay, something like this, and some print is happening here as well. Okay, now if I ask you, can you actually find out the time complexity, which means I'm asking actually, can you find the big O for the time complexity, right? How we will do it basically, let's try to understand. So the first step is basically we find out the we have to basically find out how much, just give me a second. Okay, so first we will understand what is the equation or how many cycles are there. So first of all, this is constant, right? So this is constant. I will say, let's say, I will write the function here, right? Function. It will be 1, let's say, plus. This is taken n, right? This is actually independent for loop. And now there is another for loop which is basically n. There are in like nested for loop, right? N square, right? N square. And then here if you come down, this is basically another for loop, but this is going for 100 times only, which means this is actually not n square. This is, let's say, 100, correct? This is basically my final equation. Now if I can just simplify it, it's nq, n square, sorry, not nq, n square plus 10 plus 101 basically. Yeah, so this is my fn, right? Now what I say is, the rule number 2 says that go and ignore the lower order terms, right? So what are the lower order terms? They are the two terms which are lower order here, right? These two are lower order term, right? Now if I can say it, now finally this is my thing, right? This is my equation. Now the third thing says that ignore the constant coefficient. We don't have constant coefficient here, so my time complexity is going to be big O of n square, right? So this is basically my time complexity here, right? So this is how basically we calculate it. I would say that you also kind of write some program and try to basically figure it out, right? And but I mean, roughly this is the time complexity, how basically we calculate it, right? So we have to always remember these three rules, right, that I told you, right? First you write the independent equation for all the cycles which is taking. Then second, ignore the lower order terms, and then lastly we have to ignore the constant coefficient. Guys, this is the rule, but do let me know if you feel you need any more clarification, or you want anything me to explain. Basically I can go in much depth basically if you need to, but I think that this is good enough basically for you to understand. And then in the next session, guys, we will try to understand the space complexity. Okay, space complexity as well, which is also important after time complexity, right? So any kind of program that you are writing or algorithm you are writing, definitely you are going to be asked for space and time complexity for each of this program, right? So that's why we'll try to understand in much detail the space complexity. But meanwhile, try to go through, and if you find that you need to ask something which is not clear or something you really have doubt or something, do let me know on the comment box. I'll be able to help you, right, as soon as I can do. And that's all for this video. I'll see you soon with the next video, guys. Thank you.